Hi, everyone. Welcome to our first lecture with IR 421, which is Computational Social Science. Now, in this lecture, we are going to be using R programming language. The reason for that being it is more straightforward to teach the kind of operations that we're going to be doing throughout this semester on R. You can easily do them on Python or any other programming language as well. It's more straightforward to teach them all on R. Once you are familiar with R, it is relatively more straightforward to learn Python as well, and vice versa. So my suggestion to you all is learn both. Learn R in a course like this, which teaches R. Learn Python in a course that teaches Python. Learn both, and it will make you more multilingual as far as programming languages are concerned. So this course has a combination of students who are just doing this for the first time with no programming background whatsoever. There are some of you who took a bit of programming courses before, so relatively more familiar. But for our friends who are very new to this, I'm going to begin from like first step, which is downloading R. So our programming language requires the installation of two different types of software. One, you have to download what we call the base R, which is R brain, if you will. And then we are going to be downloading RStudio. RStudio is the front end, if you will, of the brain R. It makes the brain R more user-friendly. It makes it tidier, easier to manage, especially for newcomers. So if you have never downloaded R before, and this is your first entry point to the world of computational social science or social data science with R, the first thing you have to do is download R. And when you Google download R, just like I've done here, this takes you to the comprehensive R archive network, or CRAN. From this point onwards, whenever I say, go to CRAN or download stuff from CRAN, this is what I mean, the comprehensive R archive network. The majority of packages, tools, functions, including the R itself, we download here. So depending on whether you're using a Linux-based system or you're using a MacBook or Mac Mini, an Apple-based system, or a Windows-based system, it enables you to pick your operating system here. If you're going to operate R on Windows, pick this. If, like me, you are running a Mac operating system, Mac OS, you click on this. If you're using a Linux-based system, in which case probably you're not new to R or programming at all. I'm using Mac operating system. Choose the option that applies to you. And when you click on Mac operating system, it gives you further options. The latest release, for Apple Silicon-based Macs, M1, M2, and above, which applies to me, you should be using this. For older Intel-based Macs, you would be using this one for Ventura and above. If you don't know what the version of your of the Mac that you're using, for Apple users, on the above you have about this Mac, which basically gives you what type of operating system you have. So you choose based on whether yours is a newer silicon-based Mac or an older Intel-based Mac. And you basically do the same choice based on whether you use PC or not. Now, you're going to click on the option that works for you. You download it, then once you have it, you are going to double click on it so that it starts so probably mine is older. So I'm using different computers recently, so I have no idea whether this one is M1, M2. If you're downloading an R that is unsuitable for your computer, you get a warning. So apparently I need to download the other option. I don't like really curated teaching styles. If I make a mistake, I want to do that mistake right in the beginning when I'm giving the lecture, because it makes students more comfortable with making errors as well. Okay, so I can download this version. So mine is an older Intel based Mac. So we continue, we continue, we continue. You agree to the terms and services. It is going to install R, and you basically have to use a password. It is going to install the correct version of R onto your computer. First, we always have to download R brain. So always first R, and then after downloading R, we yes, we go to trash. Yeah, yeah. So now that we have installed R successfully, we are now going to go to Google and write download RStudio, the second installation that we'll be doing. RStudio desktop. Let's close this other window. POSIT is the company that runs and maintains RStudio. So RStudio is what we call an integrated development environment, or IDE. Now, the point of an IDE is to render base programming languages more user-friendly or easier to combine with multiple other workflows or tasks. For R, for several years, we used RStudio. Today, we have RStudio, we have Positron, a different IDE. We have VS Code, Virtual Studio Code. You are free to use any one actually you like, but if this is your first time with R, it makes more sense to use RStudio, simply because of the fact that it is easier to learn on RStudio, and even advanced R users, they continue to use RStudio for a very long time. Now, once you come into this page, it once again says, before you install RStudio, first you have to install and run R. We did it just now, so now we have to, we can install RStudio itself. So choose Mac operating system version, Mac operating system. So if you're using Windows, it's going to ask you Windows-based questions. Since this is a Mac, it says, are yours, Mac operating system 13 and higher or 12 and earlier? What is my Mac operating system? I go to this menu and ask about this Mac. Mine is 1561, which is one of the later versions, so it is 13 and higher. So I'm going to be choosing 13, download RStudio desktop for Mac operating system 13 plus. And then it is going to download this. Again, R and RStudio, they integrate very seamlessly. It's easier to use them, learn them. I definitely find RStudio tidier, definitely. But every single day we have a new integrated development environment, an IDE. It is, often quite fun to test new ones. I'm very interested in this positron, the data science integrated development environment, IDE. It combines both Python and R. So apparently it's very good for labs or research groups who use both Python and R. I haven't really tried positron, but I'm really interested in testing this. But for now, we have downloaded RStudio. So download RStudio in the way that your computer downloads stuff. For Mac, you take RStudio, you drag and drop this into the applications folder. And then it is basically copying the contents of RStudio into your applications folder. So my applications folder now contains both R, the actual brain, the base R, which we first downloaded, and then RStudio, which is the integrated development environment or the front end of R. So I double click on RStudio and it is now installing, opening it up, verifying my download. It's an app downloaded from the internet. Are you sure you want? Yes, I'm sure I want to open it. Let's close these. Even though, so this belongs to previous project. So now this is what RStudio looks like. If you didn't get this screen right off the bat, you can go to File and you can basically say New Project so that you get an entirely fresh and new project here. I don't want to save the current workspace. New project, so it's opening a new project. Starts a project in a brand new working directory, an existing directory, version control. For now, I would suggest you to just open a new directory, and from this it asks you, is this a new R project? Is this a new R package? Is this a new application that you're trying to create? I'm going to teach you how to make R packages and applications with Shiny further along the way in this course. But assuming, again, this is a class in which we have a lot of newcomers to programming, I'd like to start very slow and then go from here. I clicked on this new project button here, and directory name, let's give it learning R Studio, for example. This directory is where I'm learning RStudio. And then let's open this as a new session so everything will be fresh. So it is basically opening the entire R. I can close the previous session. So this session is absolutely new, completely fresh. And I'm pretty sure those of you who are running R for the first time is like, what is happening? What is this? Before I explain to you what this is, go ahead and in this upper left corner, there is this plus and empty documents option, new file. Here, what are these? So R script is the window in which you write R code. Many of you know what a PowerPoint is. R contains a replacement for PowerPoint, Word, so Quarto. It enables you to create more detailed documentation, documents, more detailed presentations, a notebook, a markdown, a web application, API controls. I'm going to teach you what an API is and how to use APIs later on. Just simple text file. If you want to write in C++ code, you can write in C++ code. You can write Python script. Those of you who come from management and information systems departments, you can write in SQL, you can write Stan, you can write D3, you can write HTML. So even though we are using RStudio primarily as the IDE of R, you can use it as the IDE of many other functions and tools as well. So let's go here and click on R script. Now, you should have roughly 4 quadrants or 4 screens in front of you. Now, if you haven't changed anything since you downloaded R, because you can just like switch these screens as well, the upper left-hand side or the northwest is where you input R code. So this is where you input R code. This is where you write stuff. Now, the upper right-hand side, or the northeastern side, is where you have your files, you have your objects, you have your data. If you made a mistake, you can click on this history tab to go back in your sequence of operations in order to check what you did, where you did it wrong. This history tab is extremely useful in the future when, after taking this course, many of you will go into master's or PhD programs or will go into a data science job working with multiple people. You will be in a lab working with a dozen other people on the same R file. This history tab allows you to see the log or the history of the project you're working on. So you can clearly see who inputted what command along the way, who added what type of new data along the way. This is really useful further along the way. Connections. We're not going to do this too much in this class, but RStudio is extremely powerful. It allows you to log into real-time data sets from around the world. So you can establish a new live connection to a database or a data set and get live data in real time. It's for this. Tutorial. R contains in itself a dedicated RStudio tutorial. So you can click on the options here in order to get the embedded tutorials for RStudio. Of course, it will never be as good as a course taught by Professor Ünver, right? So you should just listen to me and not do this. Jokes aside, learn as many different tutorials as possible. I mean, when I was learning R years ago, I would just go on YouTube and find any new tutorial that I could get my hands on. It's a very live language, so every single day some new person invents a new way of doing things. And after a while, when you pass the initial learning curve, programming actually is pretty fun. That's why most of you do it. So actually, like following a code through of another person's tutorial on YouTube is one of the most fun things that I had back in the day. learn as many new skills as possible, watch and follow as many different tutorials as possible. So let's go back to the environment. The bottom left-hand side, or the southwest, is the output section, or console, terminal, and background jobs. So usually when you input code here, the output emerges from the bottom left-hand side. It contains a terminal option, which allows you to communicate directly with your computer's hardware and software. And that will maybe, like, in the last week, we're going to be using terminal to do some advanced operation, but until last week, you will not really be using this. Background jobs, sometimes for getting data, for cleaning data, for searching live on multiple data sets, you set up background jobs in which it runs in the background. You go eat something, go for coffee, it works in the background. That's for background jobs. The bottom right corner, or the southeast corner, contains your files. When we'll be doing data visualization, plots are going to appear here. Packages, or the tools that we use in R, appear in the packages section. Help, the help section is here. Learn R online. Task views, getting help with R, POSIT support. The community of R is amazing. Really, it's one of the most helpful programming communities around. The viewer is for viewing different types of visualizations as well. Presentation, if you are doing a presentation using especially Quarto presentation, that's where it appears. But for now, just to simplify everything, for the first several weeks, we will be typing code here. We will be looking at the data and package related components of our work here. We'll be looking at output here, and we'll be seeing most of our visualizations here as well. Now, so this is where you input R code. So how do we run an R code? We typed something here. And how do I run this? How do I execute this command? You do in two ways. Either you're going to see this blinking cursor at the very end of this is where you input your code. If you click on run, it is going to run everything that is on the left-hand side of this blinking cursor. Or you can choose the section you want to run, and it runs that. So now this is where you input our code. I'm going to run it. And it says, this is where you input our code. It says error, unexpected symbol in this is, because R doesn't really understand our language. So if you say create a beautiful data visualization and do run, it doesn't compute, it doesn't understand our language. We have to learn R's language and write things in the way R understands. So this is a very typical error message. It's like, it's not a command that R understands. Or create, it's not a command R understands. But R does understand mathematical operations. I'm going to tell you more about this in the follow-up courses, but R is very strong on statistical analysis. And so it is very natural in interpreting statistical language and mathematical language. So if you were to say 3 plus 6, for example, and either you run as is, or you can like choose what you want to run and then run that. If you run this, now it's going to understand there's a number here, there's a plus sign, and there's a second number. So your command is 3 plus 6. The way I understand this as RStudio is that this is an addition operation, a mathematical operation, whose result is 9. So it has summed these numbers for you. The same goes for any mathematical operation. Let's say, sorry, not here. So 250 minus 50, mathematical operation. I run it. It says, okay, the input that you're giving me is 250 minus 50. So I recognize the number. I recognize the second number. I recognize the mathematical operator, which is a minus sign right in between. So you're asking me to actually conduct a mathematical operation, and the result of that operation is 200. So essentially, any kind of mathematical operator, you can use RStudio as a calculator, basically, if you want. But you know, it's more, it does more than that. So let me talk about, while we're talking about numerical data types. Let me introduce you to some common data types that we'll be working with on R. So the first thing maybe I need to explain to you is that, let me see if I can actually zoom in. Okay. So one thing that I need to explain to you is this hashtag sign. These like two vertical lines and two horizontal lines. This is called a hashtag. This is called a hashtag. So in our language, hashtag tells R not to execute this part as a command. So what does this mean? So if I remove this hashtag and I say this is called a hashtag and run, it says this is, I don't know what this is. What are you trying to get me to do? I don't know what is this. So sometimes when you're collaborating with other people, when you are teaching this in the future, maybe you're going to be an R instructor yourself, you will add some notes to your students. So we do that. Or you're in a lab with 100 other researchers, so you leave a message along the code, download this data, don't do this operation in this data set, right? So you basically write notes or comments that shouldn't be treated by R as a command. So whenever you have these non-command or non-executable command words, you add a hashtag. This is called a hashtag. Hashtag allows you to leave comments on our script. Hashtag prevents the words on the right-hand side to be executed as command. So I'm now just like typing these as notes for you. If I run this, now it's not giving me an error because what R is doing right now is that it says, okay, these are hashtags. I'm just printing them as they are without trying to execute them as a command. But for example, what would be a command that would be executed? If you say, hello to R, it says error object hello not found. R is so rude, guys. It's like it doesn't even understand what a hello is. So hello, object hello not found. But then you can basically say in quotation marks, hello, and run it. It says, oh, okay, so hello. So this essentially becomes written as hello. But the actual command for this would be to print hello, in which case it prints hello either as quotation marks or as hello in. So when we remove these quotation marks from here, it once again says object hello not found. So we are printing stuff as it is by basically adding quotation marks to this. So which in that case brings me to the issue of main types of data, not data, main types of commands on R. So the first is numerical data or numerical commands or numerical inputs. So if I say 25 or 26, notice R understands that this is a number, so it paints it in a different color. When I run it, I say 26, it looks at it, oh, it's a number. Okay, 26. It responds to me in the exact same way. Now, if I say 26, 50, 25, 30, separated by commas, it says, oh, wait, there's a comma here. I don't understand what this is. What are you trying to do? I don't understand what this comma is. So in order to create what we call a vector, a sequence of inputs, we use combine function, which is C open parenthesis and close parenthesis. For example, if I want to create a numerical vector, rule number one, if you are naming something in R, don't use space. If you're going to use a space, if you want to separate two words from each other, use an underscore. This is shift underscore, depending on where underscore is on your computer or keyboard, you're going to use numerical vector. So now if I run this, it says numerical vector. What's a numerical vector? Now we are going to populate this numerical vector with some values. And we are going to combine a number of values in which we are going to use the combine function, C, open parenthesis, and let's just write some numbers in this. Let's say 100, 101, 102, 103, 104. And what I'm trying to do is that I want this combined sequence of values, which is the technical term for it is a vector, this vector, a sequence of inputs, a continuous sequence of inputs. We have to combine them. I want to combine these values and assign them into the object called numerical vector. Now, when I do this, it is going to give me another error. It says unexpected symbol in numerical vector. I understand numerical vector, but then I have these strange things. I don't understand what this is. So I'm going to link up what exists on the right-hand side and put them into the box that we call a numerical vector. In order to do that, probably the most important, let me change my keyboard because we need a specific keyboard input. I need the smaller than sign in mathematics and the dash. Now notice this looks like an arrow, right? So it is supposed to be an arrow. It is actually an arrow. What it does is that this arrow, smaller than sign and dash, it takes whatever exists on the right-hand side of that arrow and then puts them into what exists on the left-hand side and creates an object out of this. So I'm selecting all of these. And when I click on run, now, congratulations, this is your first successful R command. Notice that it now created a value called numerical vector, and the contents of it are numbers. It automatically understands these as numbers. And this is a vector which only consists of one single row and 5 different columns or 5 different numbers, which is 100, 101, 102, 100, whatever. So now, because we have assigned an object called numerical vector, I can now, instead of using 100, 101, 102, instead of doing that, from this point onwards, I can say numerical vector. Now, why are we using RStudio? Why do we love RStudio? Is because it's very user-friendly. Now, once I start typing NUM, it starts to give me commands that start with NUM. So numeric is a different command. Numeric version is a different command. Numeric derivative is a different command. You will never use these. But notice that there's a purple friend here called numerical vector, which is this guy here, the vector that we created. So because it is not a command, but it is an object that we created, the color is different. It's purple. When I click on this, it gives me numerical vector. And when I now run numerical vector, look, it is giving me the contents of the numerical vector. Now, we can do this for other data types as well. Now that I changed my keyboard into American, everything is horrible again. Anyway, we can have string comments or input. Now, string is basically words, basically keywords. Now, let's assume that we want to create a vector of countries. And I say, for example, Turkey, Germany, France, Brazil, Italy, whatever. So these are just a sequence of words, country names essentially, but R doesn't know what they are. So if I choose and run these, is like unexpected error in Turkey. Turkey is not a command. So as it is, we cannot operate this. But just like we are assigning a numerical vector, we can also create a vector of keywords. The technical term for it is string. Text values are string values. So let's say I want to create a string underscore vector. in which I'm going to combine all of these, Turkey, Germany, France, Brazil, and just like I did with the numerical vector, I want to assign them into my string vector object. If I do this and run this, it says unexpected error because I still don't understand what Turkey is at this point. So you're going to say, so maybe it's because I didn't use the combine function. That is why it's not combining. So let's add combine function in order to create a vector and then close these values. So I'm going to try using string vector with a command of Turkey, Germany, and whatnot. But again, I run this and it says, I don't know what Turkey is. Again, because again, it is trying to look for a command, whereas Turkey is the name of a country, is a special name. So is Germany, so is France, or our names. Me as Akın Ünver, it wouldn't understand me as command. So which is why for private names in this context, we have to wrap them around with quotation marks. You can use single quotation mark or you can use double quotation marks. Both are understands them. So now I'm just using single quotation mark, but I have to wrap each country with a quotation mark. So I use combine function, open parenthesis, first quotation mark, Turkey, close the quotation mark, comma. Then I need to wrap Germany in quotation marks again. So just before the comma and soon after the special name ends. I have to do the same thing for France. I have to do the same thing for Brazil and for Italy. So now I have translated what I'm trying to say into language R understands. So now notice that I use the combine function to create a vector of strings. Remember, vector is a sequence of values that follows a particular order. So in order to create this sequence of countries and assign them into string vector, I need to just select them all and I click on run. Now it understands. It created a value here called string vector. Instead of numerical values, now it understands that these are characters. These are letter characters, or string values. So there's a Turkey, there's a Germany, there's France, there's Brazil, and there's Italy in this. So every time we use a string value, we have to use these quotation marks. Any non-command text that we have to input into R, it has to contain these two quotation marks. And then we have to combine them into a vector using the C function. And then we have to do this assignment arrow, which goes to the object string vector. And finally, let's create a third type of Boolean or logic operator commands. And these are basically yes, no, or true, false values. In which case, let's say this is Boolean vector. We do once again the arrow, and we have to use the combine function as well. Now, because these are commands that are executed. We don't have to wrap them around in quotations, but you can say true, false, false, true, true. Now, just like these numbers, notice R automatically understands true, false, false, true. It changes its color. It says, oh, these are logic operators. So you're basically trying to say whether something is a yes or no, binary options. So here I select this vector as well. I run it. And now it understands my Boolean vector or Boolean operator, and it says, okay, this is a logical argument, which is true, true, false, 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 true. Anyway, now, why are we learning this? What is the purpose? I mean, are we practically crazy? What is happening? So, for the next 3 weeks, we will be heavily dealing with matrix data format. And we'll be working quite exclusively with the World Development Indicators. Those of you who took my IR202 Quantitative Research Methods course know how much I love World Development Indicators. It's both like a very professional data set, but also the data set that makes it much easier to teach both programming and beginner statistics to newcomers. It's a very easy to navigate data set. So what I want to do here, I want to combine all of these. Let's combine string, numerical, and logic vectors into one single data frame. And how are we going to do this? Is that let's first create a vector of country names. All right. So let's create an object called country underscore names. And let's combine them. Don't forget the quotation mark. So let's say Germany, comma. Notice in vectors, we are separating values from each other using a comma. Notice how each value is separated from another value with a comma. Now keep this in mind because in the coming lectures I'm going to teach you comma separated values format, and you will be asking, what is a comma separator? And comma separator is basically one of many ways in which we separate values from each other in a vector. And usually, easiest, most straightforward. And when you're typing fast codes, it's, the easiest to use as a separator. We use comma. We use comma as a separator. So we separate Germany from Brazil with a comma, China, comma, quotation marks. Say Australia, comma, say Kenya. This is a sequence of countries, just 5 values, 1, 2, 3, 4, 5. And I'm going to create a new object called country names, which is going to contain this sequence of vector called Germany, Brazil, China, Australia, and Kenya. And I run it. It says, a new value here, country names, character. Again, these are just text. And we have Germany, Brazil, China, Australia, and Kenya here. Now we'll do the same thing with create a vector of country populations, for example. And let's say population as a new object in which now I'm going to create a numerical vector in which I'm going to have a rough population in millions of the countries Germany, Brazil, China, Australia, and Kenya. I memorize it, but you would normally look up online to see what the population numbers for these countries are. Once again, I use a combine function, and roughly population of Germany is 83 million. I can write this as 83 million, but for the sake of simplicity and for you to easily follow up, these are population in millions. Brazil has about a population of 212 million. China is very large, about 1.5, 1.44. I mean, it's 1.4 billion population. Australia is not that much populated, and Kenya is about 54 million population. So this is a numerical vector of these countries' populations. I do run, and notice it says, okay, there's a population object. We have number, 1 row and 5 values, and the values that we inputted. The same thing we can do, essentially create a vector of gross domestic product per capita in US dollars. Gross domestic product is the total monetary value of a country's economy or economic productivity or economic actions. And per capita means that country's total volume of economic activities in monetary value divided by the number of people who live in that country, which is population. Per capita means per head, so per person. So these are gross domestic products per person in US dollars of these countries. So let me create a new object called GDP per cap, or GDP per capita. Let's write it longer. And GDP per capita of these countries are 16144, relatively wealthy country. Brazil, unequal generally, so it's not that high. China became hugely wealthy over the last few years, but once again, it's not that equal. We have Australia. Now I'm cheating. I'm actually looking at World Development Indicators data, which is on a different screen in front of me. I'm not going to be able to memorize all of that stuff. So Kenya GDP is lower, about $2,000. So these are basically per capita GDP. So yearly, on average, what is the monetary value of each individual citizen is within the greater scheme of GDP of that country. So GDP per capita, I'm clicking on run as well. Notice how we have now another value called GDP per capita, a new object, a numerical object, 1 row, 5 columns, which contains the GDP per capita of those countries. Now, finally, let's do a logical operator vector. So is the country an OECD member? Okay. So it is either yes or no, or true or false. Now, is OECD member is the object name that I have. Are any of these countries, so it's Germany, Brazil, China, Australia, and whatnot, are these OECD member countries? And Germany is an OECD member, so you can either write true long or T. T is fine as well. So you can say true. just T is fine. Or F false is fine. But since many of you are just like beginning R and U, I don't want to confuse you further as well. So let's write the longer term to true. Is Brazil an OECD member? No, it's not. False. Is China a member? Again, I'm cheating right now. I'm looking at world development indicators at the moment. Australia is an OECD member. Kenya is not an OECD member, basically. So I am going to run this as well. And now I have a logical operator is OECD member, true, true, false, 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 true, 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 false, false, false. Now, what I want to do right now is that I want to combine these vectors into a data frame. Data frame is many of you have taken my previous Excel course. So Excel is a data frame format. It's a grid system. It has columns, it has rows. In order to refer to a specific cell, you refer to it with its column number and row number. And in R, and also in Python, most of the time we use in these kinds of grid systems as well. Which is why, if you want to learn these things, Excel is the most incredible and the best entry point to all of this. That is why when I teach Introduction to Research Methods, it's in Excel. Once you're good with Excel, then transitioning to R or Python or Stata or SPSS, who uses SPSS anymore, but some people do. It's easier to switch to those programming languages. So what I'm going to do right now is I'm going to create a data frame made up of vectors that we have just created, which is going to go something like, let's call this countries underscore data frame, in which, in order to create a data frame out of vectors, the command is very straightforward. You basically say data dot frame base. It's basically creates tightly coupled collection of variables which share many of the properties of matrices and of lists. So I'm going to use the data frame command. And now look where my cursor is. Cursor is this blinking gray thing that blinks right in between my two parentheses right now. So I'm right at the center of data frame. I'm trying to be as careful as possible when explaining. So I press enter, and now look what happens. The first part of this parenthesis is there, and the other end of the parenthesis is like somewhere here. And look where my cursor is. Now, it is not aligned fully towards the left-hand side. When I do this press thing, it indents as if you press the tab button. So it basically pushes your cursor towards the right, which means that we can weave code structures in R like a paragraph, if you will. We write, continue with the paragraph, continue with the paragraph. When we're done, we then push the data cursor all the way toward the left. So make sure right now that country's data frame is fully merged and aligned towards the left, but line 30, well, maybe you have a different line number right now, it is now a little bit towards the right. It's indented more inward. So here, I'm going to name these variables or these vector objects in more straightforward names. So I am going to, uh, let's first do without this. Uh, I'll teach you both. So data frame, what I'm going to do is that I am going to take country names. Instead of writing Germany, Brazil, China, Australia, Kenya, I just say country names. I'm not wrapping this around quotation marks because it is a command now. I made it a command. It is a command here. It's a value. That's why it's not going to give me an error. So country names, uh, comma, population, comma, GDP per capita, yes, comma. Let me make this a little bit bigger. And is this is OECD member, close parentheses. Now, open parentheses and close parentheses are always very important. Now, our beginner friends usually um, do most of the mistakes with these like spellings, functions, parentheses, commas, and it's normal. Usually, it's when you're learning a new programming language, it is these like small errors. Maybe like opening this paragraph, opening this parentheses, forgetting to close that parentheses. It happens. Forgetting to use a comma or not adding this arrow sign. These are very normal errors. I wouldn't even call them an error. It's just like learning experience. But let's write here what we are doing. We are combining each vector into a data frame. So assuming that you have done things correctly, um, my suggestion always is if you are new to programming and coding, when you're typing on the computer, also have a pen and paper, a notebook right next to you. Write these commands on paper. Now, often some of my students complain, like, boo, it's so boring. I don't want to write with a pen and paper. I already write on computer. And the counter argument to that is most of our like cognitive ability is still based on the evolutionary processes we have developed in the last several centuries, which was strictly based on handwriting. We needed a physical paper, we needed a physical pen or pencil. And the majority of our information exchange in the last several centuries was strictly based on this note-taking practice. Now, suddenly we are like typing on this new strange brick called keyboard. And our brains are slowly adapting to this. But again, when we're learning something, our brains look for a more familiar help or support or an interface. Which is why, for those of you who are new to coding and new to programming, when you're like typing these commands on R, and this video is on YouTube, you can stop anytime you want. You can just like pause me and just go get your coffee, tea, and whatever, and like resume afterwards. Have a pen and paper. Write everything here. Like, don't be lazy, guys. Come on. Like, we're all trying to learn this, and we can't learn new stuff by being lazy. Type everything in, like, not type, but write everything in handwriting. Make a notebook. At least in your, like, first month or 2 months of programming. Write everything by hand and then type it. It makes it far easier to learn. You're going to make less errors with typing. And in terms of using our traditional cognitive capacity, it is going to stick in your mind for a longer period of time. So yes, like typing is easy and it's faster, yes, but in terms of learning, we are still evolutionary in evolutionary terms a little bit behind in memorizing, internalizing, and capturing only typed stuff. So my suggestion: have a notebook. Every single code that we write, first write with your own handwriting into your notebook, and then from your notebook write into the R input screen. It's going to be much better for you. So now, countries data frame, a new object that we created. It contains the command called data frame, which basically says convert everything that is inside this parentheses into a data frame format, like Excel, if you will. And what are we putting into this data frame? We are adding the vector called country names, so Germany, Brazil, China, Australia, Kenya. We are adding the vector population, numerical value of the populations of those countries. We are adding GDP per capita, the GDP per capita of those countries, and the logical operator, the yes/no statement to whether that country is an OECD member. So now, when we run this, we have a new friend here called data. Countries data frame, 5 observations, which is 5 columns, and 4 variables. Each of these vectors are variables, so rows, if you will. So this is a 5-column data frame with 4 variables or 4 rows. Now, let's click on this country's data frame. So go here, click on it, and you have this. A data frame, a grid, very similar to Excel. Those of you who took my Excel course already knows how to manage this. You are going to notice, for example, that we have these arrows right next to these countries. You can sort these countries alphabetically, A, B, C, G, and K. You can sort them from smallest population to largest population, or vice versa. You can list from poorest to richest, richest to poorest. So there are, just like you would in Excel, or you would have the order in which we inputted, we wrote those countries into the string thing. But at the end of the day, remember in research methods course with Excel, we would get a file called CSV, or comma separated values file, a CSV file. And then we would parse it, convert it from a comma separated text format into a fully fledged data frame format into Excel, and then do data visualization, data analysis, whatever. This is the logic, this is the background of it. Every single data frame, every single comma separated values file contains vectors who are separated from each other by commas. And the reason why we use comma, we can also use semicolon, we can also use tab, but this is the easiest, fastest, most straightforward, widely accepted way of separating values from each other with a comma. And by combining those comma separated values into an object, you create vectors. And then when you combine those individual vectors into a data frame format, you have this matrix style thing. And every single visualization that we're going to be doing, every sophisticated, fancy analysis that we'll be doing in this class springs from this logic, essentially. A data frame format, which consists of variables. So country name is a variable, contains string values. Population is a variable, contains numerical values. GDP per capita is similarly, it's a numeric variable, which are just numbers. And you have Boolean variables, which is true, false, or yes, no operations. So now, for example, if I were to do things like countries, data frame. So immediately when I write it, it automatically calls this data frame and gives me a snapshot of it. If I click on it, and now if I run countries data frame, it is going to output in the console section as well in that regard. So for example, now that you have a clear and nice data frame at hand, you can do things like check the general structure of a data frame. So SDR, the compact display of the structure of an R object. Whether it is nested, whether it has numbers or anything. So when we say SDR or structure, countries data frame, for example, when I do run, it says data frame. It has 5 observations of 4 variables. It has the following variables. It contains country names, which is a character vector, which contains Germany, Brazil, Australia, whatever. A population variable, which is a numerical vector, which contains values. A GDP per capita variable, which is a numerical vector, which contains monetary values. And a logical variable that has true, false, true, false, true, false. This is a small data frame, but imagine you have a data frame with like 10,000 rows and 5,000 columns. Because in data science, we use big data, the kind of data sets that we have to deal with are often enormous. Now we're working on a very small data frame, of course, but once you start working with larger and larger and larger data sets, these like quick checks or quick glimpses of the data set would be very useful. Another thing would be summary statistics of the data frame. So we say summary. Summary is a generic function used to produce results summaries of the results of various model fitting functions. So if you say summary of countries data frame, for example, it is going to say, so there are country names, there are 5 values here, these are characters, but when you look at population, for example, it says the minimum value that I found is 25. So the smallest population here is whose? Australia. So minimum value is 25. The median value, the middle point, is 83. And the maximum value is Chinese population is 1.44 billion people. The first quartile, the third quartile, and the mean, the mean of the statistical average of the values. And the same goes for GDP per capita. The minimum value, GDP per capita, is 2036. This is Kenya's. The median GDP per capita in that segment. The maximum value, the mean value, third quartile, first quartile. Remember, in research methods Excel course, we did summary statistics manually. And here you do summary statistics or descriptive statistics with the function called summary. Now, we can do, what can I teach you more? Let's do this. We can access a specific column in a data frame using the $sign, which is this. Now, for example, if I want to access the population column from countries data frame, the moment I type in the $sign, it gives me the options of variables that are in the country's data frame. It says I have some names of countries, I have some lists of population, I have a thing like GDP per capita, is this an OECD member or not? So if, for example, you say country's data frame population and run, it is going to give you the contents of the population numbers in those countries. Or you can access the data for the first country in the data frame, in which case you would do country's data frame. And in order to reach the first country here, notice when trying to access a specific row or a specific column, I change the parenthesis type. Instead of the curly parentheses, now I'm using the bracket parentheses, the edged parentheses on the computer. So if I say data for the first country, so the first value in the list, comma, and nothing. So let's see what this does. So in my data frame, if I adopt the ordering in which I use these values, if you say from country's data frame, first value in the bracket, which is n and nothing, is the row number that you want to extract. If you want to extract second value in the brackets, which is nothing and n, is the column number. So if I want to pull the first value row-wise, what is a row? Rows are horizontal vectors here. If I want to do column-wise, I would instead get the variables like population, GDP per capita, or is OECD member. But I want all of that data that belongs only to Germany. So for example, I say country's data frame, run Germany. I'm not adding anything in the second part if I want all of the values. But for example, if I only want GDP per capita for Germany, I would have to say first row, 1 to third. So in order to extract this, I need row 1, column 3. So the first value is always the row number, second value is the column number. So if I do country's data frame 1 and 3, it is going to give me the per capita value, which is 46,000 and whatnot. If, for example, I want the population for China, first number is row, third row, and population is in the second column. So I would basically be doing third to 2, in which case it's going to give me Germany's population number. Or for example, if I wanted to get the information on whether Kenya is an OECD member or not, I would need the fifth row and 1, 2, 3, fourth column. So it would be fifth row, comma, fourth column. And in that sense, when we do run, it says false, Kenya is not an OECD member. So what can we do? So let's say Germany underscore population, let's say. if I want to get the data for that, I would basically be doing countries data frame, edged brackets, what is Germany population, first row, second column. So 1 to 2, and I do run. And it says Germany's population, 83 million. It immediately took the values of 83 and assigned it into Germany population. China GDP per capita, let's say Chinese GDP. Then we would do countries, data frame, age bracket. How do I access Chinese? So third row, GDP per capita is 1, 2, 3. So 3 to 3. 3, 2, 3. Run. Chinese GDP is $10,500 and whatever. All data Germany. So what I'm doing is that I'm getting all of these values for Germany. In that sense, it would be countries, data frame, first row, and everything. So when I'm not specifying a specific column, I leave it empty. So I'm just telling get everything you can find from the first row and assign this to all data Germany. Now it took all of the values that belong to Germany from country's data frame and created a new object called all data Germany, and it consists of Germany's values. Let's do it otherwise. So let's get everyone's GDP per capita. So GDP per capita, both. It's GDP per capita or whatever. Countries data frame, in which case I need this for all countries. So 1, 2, 3, 4, 5, everything. So I'm not going to type anything in the first part because I want all of the rows, but I specify column 1, 2, 3. So GDP per capita values are in third column. So it is going to be nothing in the first part and 3 in the second part. I do run, and instead of a value, now I have a GDP per capita, a numerical value of GDPs for all countries. This was already, we had this in GDP per capita, but anyway, I mean, for the sake of training, I'm giving you all of the options. But the most important thing is that when we're trying to access a data frame, in Excel, we would just like point and click. We would just like select this. Now, in programming languages, you have to specify what you're trying to do with code. So essentially, we can do maybe let's also do a bit of basic data wrangling with this, like add a new column for total GDP for all countries. Now, how am I going to do a total GDP for those countries? Now, GDP per capita is that country's total GDP divided by the number of people who live in that country. Now, I have enough data to calculate total GDP because it's going to be a multiplication of GDP per capita and population. If we multiply GDP per capita by population, you reach the total GDP. So we can write this in coding terms as country's data frame But instead of accessing, I'm now designating a new object, which is going to be called total GDP. And more visually, when you see this data frame, it is going to be added as a new column on the right-hand side. So after country names, population, GDP per capita is OECD member, you are going to be seeing a total GDP column, which is going to consist of population multiplied by GDP per capita, which would result in total GDP. So in this case, the total GDP that we have is going to be a mathematical equation of from country's data frame population and multiplication in R. Let's see if I'll be able to find this. It's this sign, asterisk. So maybe I should write this. Asterisk. This is the multiplication function. It is not x. X we use for different things. So in order not to confuse that x with this asterisk sign, it's separate. So countries data frame are using $sign. So we are multiplying population by GDP per capita. So once we do this, we now have in the countries database 5 observation. This used to be 5 variables, remember. Now, sorry, this used to be 4 variables. Now we have 5 variables. We have 5 by 5. And I click on this, and now I have country names, population, GDP per capita, is this an OECD member, total GDP, which is a multiplication of population, GDP per capita for all individual countries. Yeah, I mean, we're going relatively well. I am going to continue next week from here because I don't want to traumatize you by just like overloading you with stuff. Sleep on this. Look at your notes. Next week we are going to continue from this point onwards. But thank you very much for joining me. And I'm going to look forward to continuing from where we left off in next week. Thank you so much and see you next week.